Hello, welcome. My name is Rudolf Eremyan. I came here from Tbilisi, Georgia. Um, Let me briefly introduce myself. In 2016, I joined Georgian startup Pulsar AI, where we created first Georgian chatbot framework for Georgian language, which later integrated in mobile bank system, and also it was used by different companies in Georgia. I also worked on different machine learning tools like sentiment analysis tool or news clustering. And after 2 years working as a machine learning engineer, I switched to data engineering, and I joined TopTel in 2018 and started working on data engineering projects and implemented infrastructures and different tools for projects in sport, pharma, e-commerce, and marketing. My presentation today will consist by 3 parts. First one will cover general topics that were related to data pipelines. Second part will be about AWS services. And last one, we will get familiar with different architectures implemented on AWS. Okay, if you are running modern business, most likely you considered hiring a data scientist. Data scientists can do some descriptive analysis or can train machine learning models for improving customer experience or fraud detection, doing sentiment analysis. But data pipeline is a crucial piece of this puzzle. But what is a data pipeline? Here you see just a simple schema of data pipeline. This one is a source, the place where we are getting raw data. We have intermediate steps, processing steps, operation 1, operation 2, and 3. They can be more operations, this just for example. And last one is a target, the place where data getting loaded when it's already processed. Just a brief definition of data pipeline. It's a series of steps that move raw data from source to the destination. And let's talk about what kind of source we can have. Actually, sources can be different. It can be a relational database like MySQL or PostgreSQL. It can be CRM or Salesforce, CRM such as Salesforce or HubSpot. Actually, you can just send a request to API and receive this data. Even it was a simple cases when data provider uploaded CSV files on the cloud like S3, and we just pulled it and after started processing. Regarding processing step, actually it consists by different steps. One is transformation, another one is augmentation or enrichment, filtering, grouping, aggregation. Let's focus on each of them. First one is filtering. Filtering can consist by different steps. For example, also it's based on the business rules. For example, for numbers, right? Some columns should have only positive numbers, not negatives. Some values cannot be less than 0 or larger than some specific threshold. It can be provided by business, or it can be just naturally, for example, weather cannot be like larger than plus 1,000 or minus 1,000. Theoretically it's possible, but in real case it's another place, for example, for filtering, when in my case, there was a project when we expected from data providers some text based on the keyword. But data provider sent a lot of noisy data. And we use this kind of filtering to remove noise, because this noise later made the problems for machine learning teams. And this is very important to do high quality filtering to help machine learning teams to have less problems, let's say so. Filtering possible by keyword or by context. It's more advanced way when you train machine learning model to understand the context of the string and filter by the context. What's interesting that you have to collect statistics about filtered data. How much data you filtered out and how much remained. Why it's important? First, that later you will ask your data provider that your data struggle and you're providing noisy data, and you can exactly show on which place it failed. it was text or it was numbers and so on, like different validation steps, and you're collecting statistics about that validation rules. Transformation. Actually, from transformation side, it can be just a change in date format. A few days ago, for example, one of my clients asked to change the date time format to a UK format. I didn't know that it was some difference, but it was also dictated by business rules. They can be, for example, transformation in text, just changing from lowercase to uppercase. Also very important to handle null values. People getting confused that sometimes people thinking that null values is zeros. They are not zeros. You should think about null values as unknown. And it's also task specific how you will handle them. Sometimes you can put maximum value or mean value. Sometimes you have to have it as it is, like just have null values. Augmentation, this is enrichment part. For example, you have coordinates, latitude and longitude. And based on these coordinates, you can know also about country, city, maybe altitude. We analyzed track and field data, and we knew about coordinates of the venue when this championship happened. And based on this, we started collecting information about weather to know athletes' performance during different weather conditions. And we were able to do this using this only two longitude and latitude. Just imagine, having two of these columns, we were able to make our datasets very rich and help data analyst team to do some cool analysis and try to find some interesting insight in the data. Another possible way for data enrichment, that just extracting day of the week of the year from your dates. You can make it more informative, and later these aggregations can be run also on this kind of specific data, maybe weekday, it was weekend or working day, and these kind of nuances. It's all related to enrichment part. Actually, grouping and aggregation, in case of grouping in the column, you have a lot of different groups. You can just aggregate them together and have total value or average value. And all of this is processing steps. And destination, this is a place where our prepared data getting loaded. It can be data lake or data warehouse. It also depends, that we will consider both of types, how we can implement them on a stream. Actually, this is 3 stages, and people quite frequently get confused what's the difference between ETL and data pipeline. Actually, ETL is a subtype of data pipeline. Data pipeline don't necessarily transform the data. In case of ETL, we have extract, transform, load, 3 stages. In case of data pipeline, it can be just move data from A to B, like found. It can be moving data from one database to another database, or it's not necessary to run transformation operation. Second one is data pipeline don't necessarily finish after loading data. In case of ETL, it runs and ends, like it's one-time job. Extracting, transforming, loading to the database, and that's all, that's done. In case of data pipeline, they also can be a real-time analytics platform like streaming data, and events come continuously. We are receiving it without stopping, okay? Different examples, like for example, you are monitoring Bitcoin price, or you are running something like Google Analytics, you are receiving these online events from the web page. And this streaming. And third one is data pipeline don't necessarily run in batches. As I said before, like ETL, in case of ETL, during some time, data getting collected, and ETL running on scheduled basis, like in the end of the day, or maybe during the weekends, when we collected a lot of data, we are running ETL to process it. In case of streaming data, like it's not running on interval, it's running continuously. And during my presentation, I want to talk about 3 types of architectures, data pipeline architectures. First one is page-based data pipeline. Second one, streaming data pipeline. And third one is a Lambda architecture. Let's talk about each one briefly and what is the difference, and see what's the difference. Okay, Batch-based data pipeline. Actually, as I said before, data getting collected during some interval, and we are running our ETL on scheduled base, like end of the day or weekends. And example and use case of this kind of batch data pipeline can be, imagine you are running your shop on Shopify and you are collecting your transactions. People paying or transactions can consist payments or refunds or different situations, a cancellation or card expired, and all of these transactions getting collected during the day. In the end, by the end of the day, you are running your ETL to process all of these transactions and load this data to the data warehouse, where further data analytics team can do different kind of analysis like customer churn prediction, or it can be customer lifetime value. All of these metrics can be calculated, but to make it possible, first you have to load the data in prepared way to the data warehouse. Actually, this is about batch-based data pipeline. We already talked about streaming data pipeline, the way when it's also known as event streaming. You are receiving this data continuously. For example, I had one project. It's kind of deploying infrastructure for in-house Google Analytics, kind of in Google Analytics. And each action, each interaction of the user on the website, we try to collect each interaction of the user. And this is example how this can be implemented. Like user clicks or user moves mouse, and we are receiving these events. And it comes to the kinesis first, and after kinesis we moved it to the, there was actually two places to move, one to the data lake to have raw data, and another one, we moved it to the Elasticsearch, and after we had Kibana for monitoring live events. Two purposes. Sometimes you want to know the kind of speed layer, we will discuss it during Lambda architecture, and you want to know something quickly, but you also want to have raw data because machine learning team can use it to train machine learning models for different purposes. Actually, this is about streaming data pipelines. And third one is a Lambda architecture. A Lambda architecture combines both batch data pipeline and streaming data pipeline. You see two options of Lambda architecture. We have data source, real-time layer, also it's called speed layer, batch layer, and they're getting combined in the serving layer. Serving layer, just think about some database like MongoDB, for example, where data getting indexed. Another option, it's Lambda, but you have as a serving layers, so you have separate serving layers. Here is one serving layer, and in the second case, there are separate serving layers. One of the problems with Lambda that you have to have two tech stacks, like two stacks, one for batch processing and another one for stream processing. And maintaining this kind of infrastructure can get problematic on enterprise level. Also, your data should be synchronized. Like when you have this in separate, in case of some problems, in the future, you can see some mismatch between the data. Actually, yeah, this is a problem of Lambda. There is another one is Kappa architecture, which is a bit new, comparing with Lambda. I will not cover it here, but actually, the goal of the Kappa to have one stack instead of two stacks, and it's kind of simplified version of Lambda architecture. Here, I covered three different architectures of data pipelines. It's batch, it's streaming, and Lambda. And now I want to talk about AWS services that I personally used during my data engineering projects. Okay, you see the list of AWS services. Maybe it's overloading here, but I especially did it if someone wants to take a picture and know about having these services. But actually, the first one is S3, or Simple Storage Service. By AWS, it enables users to store and retrieve data at any time, at any scale. You can create your data lakes on S3. Actually, S3 allows storing structured, unstructured, semi-structured data in different formats. They also different storage classes. For S3, if you're going to use your data infrequently, the infrequent storage class. Actually, when you are putting your data on S3, it stores it in 3 different availability zones. But for cost optimization, you can have it like, you can choose one zone infrequent access class. This will this will reduce your cost, but be aware that there's some risk related to this kind of decisions. Second one, Athena, which is interactive query service. Actually, you can use standard SQL to analyze the files that you stored on S3 in your data lake. And the ways to optimize Athena, actually, let's do this way. Athena supports different types of file. It can be CSV, JSON, Avro, or also column-oriented data files like Parquet or ORC. It's recommended to use a column-oriented file to optimize Athena. Actually, I stored my files in a Parquet format. Also, it's recommended to compress your files. For example, make it in gzip format. In that way, you will reduce the size of the files. Actually, it will affect on the price. And also, this will improve Athena. Actually, it will improve working process of Athena. Let's define it this way. Also, partitioning, very important. When you put in data on S3, it's possible also to create a set of buckets. You also can create folders. And with these folders, you can do partitioning. What's a partitioning? Like you can have folders structure like year, month, and date, even hour. When you do this way, now think about like you're writing select something from the files, and you can filter out anything that's not related to your query. Like you want to get data only from January or March, and with partitioning, you will eliminate extra data. Why it's good? Because Athena charges $5 per terabyte of scanned data. And there are also extra charges. Actually, what's interesting, we'll say extra charges, but quite frequently, these extra charges make largest bill for you. Actually, a few times ago, I ran projects. I just checked pricing pages of AWS. It was nice, but after 2 days, I got a $500 bill that I didn't expect, and it disrupted my project's budget. Actually, be very careful with AWS pricing. Even if there is an AWS calculator you can use, but you need to be a bit skilled to understand all the details. Otherwise, be aware that charges can be very large. Okay, in case of Athena optimization, we said Parquet format, compression, partitioning, and actually better to have a bit larger files. Instead of having a lot of small files, just combine them together. Maybe a few megabytes instead of having a few kilobytes of data, okay? This is about Athena. Lambda, which is serverless event-driven compute service. Actually, what's good in Lambda that it supports Docker. And I Dockerize some of my projects and just push it to an Elastic Container Registry. This is something like Docker Hub on the AWS. And you can configure your Lambda to use your Docker image that exists on ECR. And this is kind of tricky way to reduce your costs when, if I'm not wrong, Lambda provides 1 million runs for free during the month. And imagine you are running a startup, you need to save you some money in data collection from different sources like Google Ads or Facebook Ads. You can schedule your Lambda to run on scheduled way, like every day or every 4 hours. And pull this data from Facebook or somewhere and load to database without spending money because it's like you have some space for running it for free. This is kind of tricks that you can run if you want to also save money. DynamoDB, it's fully managed serverless key value database. In case of DynamoDB, I had a case when we parsed the athlete's web page, and each athlete had a unique ID. And I used ID as a key, And in the value, I just stored JSON information about which page we already parsed, and this kind of metadata about athlete. This is kind of one example how you can use key value store. Key value database. RDS, Relational Database System Service, collection of our database services. It can be Amazon Aurora with MySQL compatibility, PostgreSQL compatibility, MySQL, MariaDB, PostgreSQL. What good is with RDS that you can easily deploy your cluster in multiple availability zones very quickly, and also making backups. To make a backup, you just need to configure a few configuration, and it will automatically start making backups as well. Like, it's quite fast to run your cluster, database cluster with RDS, but still be aware about pricing nuances because you are running cluster in different availability zones and moving data between different availability zones or even regions. Yeah, there is this kind of nuances that you should take into account. Redshift, which is a fully managed data warehouse, it's able to actually store data from 100 gigabytes to petabytes of data. If you want to run analytical database, just consider Redshift. Elastic MapReduce, it provides big data platform. We say EMR, you can run, for example, your Apache Spark cluster or Hive. Actually, I run Spark cluster. It takes just a few clicks to make your cluster ready. And what's good with EMR, that there's two options. One with step jobs, and another one is Jupyter Notebook. I think most of you use Jupyter Notebook to just do some analysis quickly. Same, it's possible to do with Spark cluster, but not on the few megabytes of data, but gigabytes of data. But the same way, you have a Jupyter Notebook, you're loading this from S3 and running your analysis with Spark. It's quite comfortable and easy. And when you are already, when you have a code and you are done, you can make your code, you can move your code to the Python script, and after use step jobs. What is a step job? You have a pipeline, and one of the processes is running your Spark cluster, right, to process the big data. And for that, you don't need to have your cluster running 24 hours. With step jobs, you can say, okay, run cluster when you need it. Run cluster, make these calculations, store it somewhere, and terminate your cluster. That's all. With this way, you will save money, and yeah, you can do it quickly without running your cluster 24 hours. Glue, which is ETL extract ETL service, actually it's for data cataloging. Imagine you have what it does. You have a lot of files on S3, and Glue runs its crawler, and it goes through your files, first understand the file of data. It can be CSV or JSON. And after it tries to scan schema, predict schema, understand properties, and in the end, you have metadata about your data. With this way, Glue can create tables, and you can use these tables to run queries from Athena, but not only from Athena. Data pipeline, this is another service that allows moving data from different AWS services, between two different AWS services. We will see difference between Glue and data pipeline on the next slide. Kinesis, which is serverless streaming data service that makes it easy to capture, process, and store data streams at any scale. Actually, Kinesis, there's 4 Kinesis services, one for video streaming, for another one for data streaming, capturing data streams from in parallel from thousands of services and gigabytes of data. Another one, Firehose, the Kinesis Firehose, which is streaming ETL service. And what's cool that from Firehose you can store your data on S3 or in your data warehouse immediately. Like you're receiving data in Kinesis. From Kinesis, you're configuring data Firehose. And from Firehose, you can run 2 Firehose, one that stores data on S3, another one that stores data on Redshift. Actually, this is architecture that we implemented for the project. And And last one is the Kinesis Stream Analytics service that allows using standard SQL for running queries on your stream data. Last one is step function, which is serverless orchestration service. It allows to orchestrate workflows based on the AWS services. Okay, this was a bit a large slide. Actually, what we covered now, we know about three types of pipelines: batch-based pipelines, streaming pipeline, Lambda pipeline. We know about AWS services used for data engineering. Now, time to combine these two types of knowledge together and see how we can implement these architectures that can be used in the further for your projects as well. But first, let's briefly, what's the difference between Glue and data pipeline? Glue is serverless, and also Glue provides support for the Scala and Python. Opposite to the Glue, AWS data pipeline provides support for the wall tools that exist in the EMR. It can be Hive, Spark, and so on. And data pipeline is not serverless. When you run a data pipeline, you have to pay not only for pipelines, but all the related sources that relate to your pipeline. In case of AWS Glue, it's running in the Apache Spark framework environment, and it's called a data processing unit, and it's built for every second of use. Like, this is a difference. Here, you don't care about server side, but here you have more access to manage your infrastructure, but you also need different kind of skills to do it. Think about these two services: AWS Glue for cataloging, data cataloging, and AWS Data Pipeline for data transferring, sorry. For data transferring and data cataloging. I had a case when I used AWS Data Pipeline when I needed to move data from DynamoDB. I wanted to have backup of DynamoDB data on S3, and for that purposes, I used data pipeline. Another case for AWS Glue, data provider uploaded a lot of data on S3, and we needed to quickly read this data and provide it. Actually, you can read this data and put to a machine learning model. And that was using Apache AWS Glue, we were able to implement this solution. This is the difference between Glue and data pipeline. Okay. This is one of the architectures that's possible to implement on AWS. Here's the links if you want to play with this, or even with CloudFormation, you can quickly have this infrastructure and play with this. S3, we already talked about it. We have what's the problem? You are working as a data engineer, and client says, your manager says, okay, client want to provide data as a CSV file. They don't have API, just uploading on S3. You are a data engineer, and we want to get it ready in our database. How you will implement it? Data getting loaded on S3 bucket, and it's possible to trigger Lambda when data uploaded on S3. And this triggers Lambda, and Lambda runs our step functions, this pipeline. What happens next? First is validation. Remember, validation is crucial. Without validation, probably you will provide this data to machine learning team with a lot of problems. And after them, they will have problems. And after doing the call, everyone will start blaming each other why we stuck with deadlines. Validate it carefully, have accurate data. This is important. Here, we are validating data. If there is errors, we are putting it in error folder. When we put it in error folder, actually this is icon of SNS service, simple notification service. This allows sending notification. Send notification to engineer or anyone who is taking ownership for this project and notify that there is error. If it's okay, run in schema, Glue crawler. This understands the schema of the file and creates meta table for it. Run in transformation, we already discussed it. Making it Parquet format, optimized for running with Athena. Also partitioning it and compressing. And why we have second crawler? Because we changed our data format. Like after transformation and enrichment, our data became a bit different, and we need to run it second time. This is one architecture that you can experiment. And second one for real-time streaming analytics, called a real-time streaming analytics pipeline. Imagine you are creating Google Analytics platform for you. A user interacts with the web page. You are receiving events. It clicks and you are receiving it. Actually, here also can be load balancer, and because a lot of requests come in. And after this load balancer puts these events to the Amazon Kinesis. From Kinesis, you can, using Firehose, you are putting raw data on S3. This can be used in the future, because also why it's important to have raw data, because during transformation, different step of transformation, there can be some problems. With raw data, you can also make debugging easier. You have raw data, and you run it manually and see what happened in the intermediate steps. With raw data, after we are using Kinesis Analytics and Lambda. Actually, here I would change. My approach was just using Firehose to put it in Elasticsearch, and I had Kibana for monitoring. Here it's another way, like they are analyzing it and sending a notification. For example, when Bitcoin reach some price, you are receiving a notification if you are a trader and trading Bitcoin. This is streaming data pipeline, and also here's a link if you want to play with this. Actually, we have a few minutes. This is different kind of architectures. You can take an image if you need. And AWS Patch that I wanted to mention during my talk, it's a large-scale computation service. Imagine you want to parse web page, and it has very complex structure that you need to click, wait until data loaded. And which way you can do this? Which way I did it? I created this parser using also Selenium for automating these steps. After Dockerized it and pushed on ECR, Elastic Container Registry. With AWS Patch, there is a queue where you can put your jobs, and also you can make a job definition that it use that image that you created and run these parsing commands. Now think this way. You are putting links, and each web page link as a job, and you have a queue, and you have also your cluster, and it started processing. And this way, you can process 100,000 of web pages in parallel. Also, it depends on your budget. But one tip that what I figured out working with AWS Patch, that you don't need to create very short jobs, like few-second job or 10-second job, because transition between job steps is getting a bit lower. Better to create batch, put batch of URLs for one job. In this case, you will parsing one job will take more than 1 minute, and for AWS Patch also it gets okay. But few-second jobs, it's not. Actually, it will work, but yeah, the cluster will run longer. Better to make batch of URLs to put as a one job. With this way, I was able to parse hundreds of thousands web pages in just a few hours, even less than 1 hour. Also, it depends on the size of your cluster, because this run in parallel. Actually, yeah, I finished my presentation. Thank you very much for listening. These are just the links. If you have questions.
Now it's time for questions.
Yeah, thank you very much for the great talk. You mentioned that you, if I understood correctly, you expose, sometimes you expose the S3 bucket to your data providers in order for them to upload the data. How do you do it actually?
Actually, it's possible to configure your permissions when you it's single URL or how it's called. Actually, we can talk about after presentation, but it's possible to configure permissions that a client has access only to the specific bucket, and they're uploading it to the bucket.
So a client needs to be on AWS as well, right? So the client needs to have an account, and you expose the permissions for the concrete account?
I don't remember it exactly, because I don't have complete ownership on our AWS account. But at least, yes, you can provide access with some limits. At least you can create user in AWS account and make some restrictions in the rules. At least this is possible. But I think there is also a second option that we can check.
Thank you.
By the way, what if interesting situation happened? Data provider, after having conflict with management, removed all the data that he uploaded on S3, and better to have copies of this data. Also, yeah.
Any other questions?
Thank you. Let's say the data provider uses Excel. What should be done in that case? Let's say should the data be put in Google Sheets and read in that way, or what would you do?
Actually, for example, a simple case when you're using pandas, there is an option to read, as you read in CSV, also you can read Excel file. And that's
like
absolutely not a problem, but very important to ask your data provider to provide in the expected format. Because sometimes they create in this Excel in a very fancy structure with some visualizations, and it's getting hard. Just saying, okay, we're expecting in this format, this column names, for example, and that's all. Like, they should upload it in the expected format. You can provide him some example file, like some sample file.
Yeah, sorry, it's me again. So you mentioned the fire horse, right? So the thing that like gets data from Kinesis and puts it to S3. Do you know if it's like, does it just put the files to S3 without any partitioning, or you can configure some kind of partitioning?
Partitioning?
Yeah, like for example, if you want to partition your data like by date or by hour or by some contents of the records.
You know what's
possible? Do you know if it's possible or not?
I can't tell exactly about that if Firehose can do it, but it's possible definitely to bind a Lambda function to Firehose, and it goes from Firehose to Lambda function, and it actually runs this partitioning. Because I remember when I put my data to Elasticsearch, it was in the middle was Lambda that transferred our data and after put it on Elasticsearch. And same way you can partition it.